Hello folks, welcome to another video. And this video we are talking about we will be taking a look at area concept. So what is an area? What is an Ospf area? Okay, in short, the Ospf area concept is how to manage the frequent updates that if network goes down and comes back up, or for example if an internet fluctuates, like goes by what they call like if an interface flags and it goes down and it comes back up, goes down, comes back up, so that is called that is just up and down. So what it means, within an area they have their own internal updates that they send if an interface goes down, for example, and comes back up. So to, like for example, if the routers, for example, are 50 routers in here, so the problem will be then too many advertisement will be, or too many updates will be going around, which can cause a network delay within an interface, within the network. If the network is flat, for example, if like 200 routers, they are just a flat, and they are only in one area. That area could be burdened by a lot of traffic going on inside the network. So the concept of areas is very important in Ospf because it manages the traffic between the areas. For example, if you have here in area 0 here, then the area 0 updates will stay in area 0. I mean the detailed update, that's what I'm talking about. That includes the link updates. For example, if link goes up and down, and that includes like any internal thing. I mean that's the main thing, just like advertising and network within an area. So that is called like LSA type 1 and type 2. Type 2, the DR gives the updates, it gives the attached routers to the other neighboring routers. So the area mainly is to reduce the flood updates that would slow the network down. If they put like 200 routers in one area, that means like that area will probably slow down. I mean, if something is wrong with the router is within that area. So to chop your network to have a faster rerouting capabilities and everything, so you will have a less traffic going on there. Then the area will simplify your traffic management. So that is the main thing that we have in area. So for example, we are segmenting from one area to another area, from some routers to another router. So we put in a different area. They will still learn the network from each other. But the thing is, instead of having a detailed information within, because as every area they have every link information, so they have a detailed information. Any router has a detailed information with detailed information that any router is within that area has. But if they're in a different area, then they will have the brief of it. For example, that is called LSA type 3, which is an information that tells the other routers within the other area. Like the ABR will tell them, for example, the ABR is called the router that sits between the two areas. So that area will tell them, that ABR will tell the other area, if you want to reach, for example, 192, this guy, if we put another area here, this guy will tell, because it will be into two areas. For example, this one will be in area 0, for example, and here I mean, we will configure the areas, but I'm just giving you the feel of it. If we have an area behind on this guy and this router, this router will become a ABR. So this ABR will tell, because it is connected to the area 0. For example, this was an area 0, so this area 0, this router will tell to this area 0, to this area. He has the information, all of the router is connected to this area, and at the same time it has the router is connected to this area because it is in the middle. But this router is right here, for example, they will not know the routers that are in the area 0. So they will tell the ABR will tell them by sending a summary LSA call LSA type tree. The ABR will send it to them, say, and will tell them, like, if you want to reach 192.168. For example, 192.168.34.0/24, please come to me, so I will get it to you. So, and there the flooding update that would go on into one area. For example, if a network is flapping in the area, within the area, that flapping will not be felt by another area, will not be bothered by another area, because they have a different area ID. So they will still know it, I mean, how to reach, but the flapping in the network will stay in one area. So that means like you are segmenting and managing your traffic. Does that make sense? So now enough is enough. Let me configure an areas. For example, now what I will do, let me just put this guy. I will put this link right here into an area 0. Just that link it right there. And also, before I do that, let me put this guy here. And before I do that, and if we had a switch here, all these 4 routers, we will not have this one, by the way, if we had a switch in here. So all the link right here, they will have one IP address, one network. They will be a member of one network, and that network, they will have I mean, one DR and one BDR. All these 4 routers will have one DR, would have one DR and one BDR. If we had a switch in here, they would be connected to this switch, so the switch will just be in the middle like a hub, and then they will, for example, if they are member of one VLAN, so they will have they would have one router, one DR and one BDR. But now we don't have a switch here. Every router, I mean, every 2 routers, they are connected to each other. So every segment between the router, it will become, I mean, we're gonna make it, or it will become an area. So if we make it this one in area 1, which I'm going to do it now, let me make this guy area 1, and if I make this one in area 0, I'll make it this one in area 0. Let me put this guy here, area 2. I'm gonna make it this guy as an area 2. Okay, if I make this guy an area 1 and make this guy these 2 links right here, I'll make it an area 0. So by normally or hierarchically in Ospf, every area must connect physically to the area 0. So area 0 is called backbone. Area 0 is called backbone. It's called backbone. Any other area are any other areas, let me put it as here, are normal area, areas, whether they are area 1, area 2, whatever the name you do it. So let me put this guy on a star right here. yeah, so that's what it is. Area 0 is called backbone area, and any other areas are called normal areas. Okay, so now I'm going to make this guy and as an area 0, and I want to make these two other guys area 1 and area 2. So every area I will show you every area will have their own information stay in their area. So that's called LSA type 2, type 1 and type 2. So this area, this routers will be a member of these routers they will be a member of area 0. So when we say show Ospf database, I will execute that command. These routers, they will just show us any router that exists in area 1. So it should be 1 and 2. So in area 1 they will show us 2, because 2 is a member of area 1 and it's a ABR, is called area border router. It will this area will show us the members that it has as that LSA is called type 1. So that type 1 will tell us that R4 and R2 are member of area 1. And here I'm going to make it another area, which is I'm going to make it area what do I do? I'll make it area 3 in this case. So and this one, the area, these two routers will tell us, this area 3 will tell us the R4 and R3 are in this area, and this area will tell us R2 will tell us area 2, R1 and R3 are member of this area. So let us configure. This is the IP address that was it's configured as a loopback /32, and let me configure this guy. Sorry, I should have done it before. I've configured it, but I forgot to put it here. To put it on here, and give me a sec. 4/32, and I have here 3.3.3.3/32. Okay, so let us start configuring on this guy. So I will say we have the interfaces already. I configured the interfaces. So we have the interface IP addresses just to make easy the job. So Ospf 1 router ID 0.0.0.1, and then I will just show IP route, because I want to know include connected. I just want to see like how many network that I want to advertise. I'm advertising this guy. Okay, 0.0.255. So this network is a member of area 0, right? So let me put area 0, and the network on here 192.168.13.0 is a member of area 2. This network right here, this network right is a member of area 2, and I will advertise this network as an area 0. That's just I chose it, area 0. So we are done on R2. Sorry, on R1, and let me go back to R2 and then saying show IP route is include connected router PF router ID 0.0.0 to network 192.168.12.0.0.0.255 area 0, because this network is a member of this, and then network 2.2.2, I'm gonna make this guy a member of area 0 as well, and the network below that is 224, so 24 will be area 2, area 1. So we made this one area 1, so we're going to do it area 1. Okay, and you're just going to do, let me go to R3. Okay, do show IP route include connected, and then I'll say router Ospf 1 router ID. Always remember router ID 3, and the network. Let me area 2. I'm going to advertise on area 3 as area 2, and the network 192.168.13.0. Sorry, 255 area 2, because it's a member of area 2. And then let me get this guy area 3 is 34, so I put it area 3 as 34. Okay, let me go to I think I didn't configure these two interfaces, so I will come back for it. Do show IP route include connected router Ospf 1 router Ospf 1 router ID 4.4.4.4 sorry 0.0.0.4 network 4.4.4.4. That's a loopback, so I'm just gonna advertise it in, I can advertise in area 3 or area 2, whichever I want. I will advertise in area 3 because I'm on R4, so I am connected to 2 interfaces. Okay, so this one will be, this area will not connect, it's not hierarchy, so it cannot connect it to to area 0, so I will talk about it, but now just let it be as an area 3, but it will not have any reachability on here, because physically every area must connect it to the, like these areas now, they have a router that has an interface to the area 0. So this will have reachability of Ospf area 0. This will have reachability. So let me just take it out for now, so you don't have to confuse it. I'll take it off. So, and so you will not have a confusion here. And okay, let me just this guy do in area 1. Do show run interface Ospf. I'm gonna remove it. Okay, so I have not so network, now I have a network 192.168.24.0.0.0.255 area 1. So now I'm okay with this one, and then let me go to R1 and delete the router. And, sorry, not R1, R3. Yeah, 34. We don't have any 34 anymore. So do show IP interface brief. I have okay. Interface gig 1/0, no IP address, and shut down. That's the gig that was here. And then let me go R4. Do show IP interface brief 34 interface gig 0/0, no IP address. That's how you take off the IP address and then shut down. Okay, so now if I say do show run section Ospf, that's a good command. Now I have advertised on this R4. I'm on R4. I advertised 24 on area 1 and 444 on area 1, and the router ID is this one. Let me go to R3, show run interface Ospf. So I advertised it at 13, which is here, and the 3. Yeah, because we only have that one. So let me go interface serial 5/0, then no shutdown because I didn't configure that one. So 192.168.13. Do I have configured that one? Let me check it. Oh yeah, I already configured it. Nice. But no, I didn't say. Okay, the other R1 I think I did not configure. Do show run section Ospf. Yeah, I configured it. But so let me go. Do show run interface serial 5/0, because we want to know why this interface why this segment they don't show us why R3, for example, why R3 do show IP Ospf neighbors, why R3 doesn't have any neighbor with this one. That's what we are troubleshooting, and we got the troubleshooting easy because this interface is shut down. So no shutdown. Now you will see, it will come up. So R3, R1 has IP Ospf neighbors, already has a neighborship relationship with R2. So now R2 is the BDR, because the problem is because we configured this one first. So if I say do clear IP Ospf process, and you say yes, then R2 will become the DR for that segment, because this segment R2 must be a BDR, and this segment R4 must be a DR, and this segment R3 must be a DR. That's what we want to see. So now do show IP Ospf neighbors. We see now R1 is the BDR, R1 is the BDR, and R2 is the DR. So R2 is the DR. See, R2 now is the full DR. Okay, if we go to R1 now, R1 does not still see this guy. So let me go this interface as well. Interface gigabyte 0/serial 5/0. Do show run interface serial 5/0. I'm just troubleshooting on this one now. So now this one is not off, so it's not shut down. So let me try if I can ping on R1. I cannot, because R1 has a problem. Do show run interface serial 5/0. So still it's shut down. I thought no shut. I thought I said no shutdown. Yeah, now it comes up. Okay, now it should be two-way. Now it's not coming up. So give a moment, then it will come up. Yeah, now you see it is full. But as I was talking about, in R1, if I say do show IP OSPF interface, the gigabyte, interface gigabyte 0/0, which is the interface that it connected, then as I said, it is a broadcasting network. Network type is a broadcasting network. Yeah, so DR and BDR exist. So when we say in here do show IP OSPF neighbors, now this gigabyte interface right here 0/0, we have the DR. Here the DR segment. But what about 3? Because R1 has a adjacency with R3, but instead of DR, it gave a dash symbol. What is that? Let me show you IP OSPF interface serial 5/0. Let me give you the interface, that command, and show you. This network is not a broadcast, it's a point-to-point. It is a point-to-point. It's not a broadcasting network. For that reason, we will not have a DR and BDR. Remember, I told you DR and BDR only exist in a broadcasting network, but in a point-to-point network, it does not exist. Now it's a serial, and the serial, which is here, we don't have any broadcast concept. It's a point-to-point. That's why we don't have any concept of DR in here. Okay, and that is areas. So now let me go to R1, just R1, because just for the sake, show IP OSPF database. So if I go to database, which we will visit later on, if I go to R1, as I said, every interface, every area has within the area, routers within the area, they see each other, but they don't see the other routers that are in the other area. For example, now area 0 does not see in a detailed way routers in area 1 or 2, but what it will see, in area 0, every router in area 0, they will see each other. They will see the IP address in each other. But when it's connected to other area, only the brief information will be passed by the area border router. So let me just go, for example, R1. R1 says in area 0 right here, we are in area 0. We say like this router ID is being advertised by this router ID. That means like router 1 is advertising itself and router 2 is advertising itself. So these two are in this area. And now this one is called router link LSA. That's a type 1. So type 1 always lists the network that is behind the network that is attached. So if I go to router 1 now and say OSPF, I'm just checking if I advertised this guy, and if I go to router 2, advertised this guy as well. Okay, so this one now, they have the full information. So they say now they are advertising LSA type 1. They see like these routers are the one that exist in area 1 and 2. And okay, and in a network which is still network type 2, and this advertisement router link LSA and network link LSA, they both stay in the area, and these are the one are responsible for having a detailed information. So now the BDR is advertising it is network that is connected to it. So this stays every router. So now we are taking a look on the router 1, and router 1 says it has router 1 and router 2 in this segment by advertising this router IDs. If I go to R2 now, I will see the same show IP Ospf database. You see, router link LSA is the same. It is the same. It just says, you know, I am router 1. I mean, I have a router 1 is that exists in this segment. I am a router 2. I exist in this segment, and this one, the router 2 is the DR, and it's advertising it is own connection. Okay, if we go to, for example, R3, which is in area R2, or if I go to a member of R2, because we can even see this information R3 in R1 as well, because it's a member of area 2. So if we go to, if we go to area 2, because R1 is a member only area 2 and area 0 and area 2. So in area 0 it gave us router link LSA. We are in area 2 in area 1, so in area 0. So these routers are existing in area 0, and also this the DR, and it's advertising it is in a connected network, which is on this link which is on this link right here, and that is they are connected because it is it is advertising an area 0, but it is also advertising, I think this is a better way, Ospf database router. Yeah, I think this is a better option because we see the detail. If you execute that command on R1 or any router, show IP Ospf database. Router means like show me the router link LSA. The router will tell you it has a two link is connected, and the two link is connected that is what R1 is advertising, and network 1.1.1.1 and network.192.168.2 the two links is talking about number of links. The two links is talking about is this link and this link, and also it is mentioning that it's not the DR. The DR it is R2, as you can see, 2alif.1. So it says link ID. The designated router is this one. The router ID is that one. But I am connected to 192.168.2alif.1, which is on this interface right here. And I am connected 1.1.1.1, which is on this network. If we go down to R2 will tell us as well. R2 says I am on R2 0.0.0. So advertising router here was R1 0.0 R1 router ID, and here R2 router ID says I am 0.0.0.2, and I am connected to 2.2.2.2. The link is advertising is 2. I'm within this area. Yeah, I'm connected to 2.2.2.2, and I am the designated router for this segment, and my link that is connected to me is to 192.168.2alif.2. And okay, that's for area. Look, that is. We are on R1, so R1 advertising these two links, and it says as well, R2 told me, R2 told me, he is also R2 also advertising two links, which is 2.2.2, and also he is the DR, and he's advertising to 192.168.2.2. That is his connection. And area 2, R2 is connected to area 2 as well. It says I have two links as here. The two links because he is still R1. He says links to another router is a point to point. I have a point to point link, and this is 2 because normally it should be one LSA type 1, but now it's 2 LSA type 1 because one is verifying that the router ID of the neighboring router, which is R3, is R3, and it is the which is the R3. It's just the one, because this point-to-point network type, it has a 2 LSA. Instead of the DR, it has a 2 LSA type 1. So one verifies the neighbor ID and the neighboring router, and it says the neighboring router ID is 00.0.3. That means like I have a neighbor connected. For sure, there is a neighbor connected to me, which is 0.0.0.3. And the other link I'm advertising is my link that I am connected to, which is 192.168.13.1. And also there is and the loopback, sorry, and the link connect and the subnet, the network that I have is 192.168.13.1. This is the link in here. So I think that's the end of it. Okay, let me just repeat here. R1 is still advertising. It says I have a network connected, network call point to point, and the neighboring router is 0.0.3. That means like it's a verification of this router, as I said. And it says the router interface that I have, the interface that I have is 192.168.13.1. That's the link right there. And it says I have a neighbor, and the network number is 192.168. That's a network that it has, that this network right here, 13.0. And he says I have an R3, so R3 is advertising on his network as well. He says it is advertising 3 links right here, and one link is 3.3.3, and one link, one extra LSA type 1 is a verifying for his neighbor. So he says my neighboring router is router 1. So that's why, since it has a point-to-point network, you always have additional LSA type 1. And it says that the link ID that I have, he says that connected to R3 is 192.168.13.3, which is on this guy. And the network is 192.168.13.0 is this one. Wow, but this information is type 1. So if we go, this information stays this area and this area as well. So if we go to network LSA, it says the router ID is for area 0 is this one. So router ID says R2 is advertising, and it's advertising is connected network. It is a designated router, designated router, yeah. And it says the attached router is for this segment, because they are always advertises the connected routers. So it says the router is connected to this area 0 is me. It's me and R1. So well, you see, the attached router for this segment is R2 and R1. If you go to R2, it's the same. Show IP Ospf database router. Still, it's advertising. R1 is advertising 2, as we said in here. 1 is 111, and we have seen here as well. On R1, and the second one is the other link is 2.1. The second link, and it says, okay, and R2 is advertising it is network, and at the same time it is a loopback network, and it is IP address connected to. And if you say show, instead of type 1 LSA, if you say the router is a type 1 LSA, if you say network LSA, which is type 2, it will tell you that exactly in the same information that we have seen in here, it stays in here. It says R2 and R1 attached on this interface. If you go to R4, which connects to R1 here, it will just show you IB Ospf database. It will just show you that it has that is area 1, and it has only connected what is the show IB interface brief. Oh, it has, okay, this 224 up and up. Let me go show IB interface brief if the interfaces are working. Oh yeah, this one I didn't even configure, that's why. Interface gig FA4/0 no shots. IP address 192.168.24.255.255.0, and excuse me for that. OSPF1 network on this. Area 1. So now R4 will have good information. Yeah, now it has a lot of information. Before it had only this one because it has only this one because it only had area 1 information. So now R1 says we are in area 1. It doesn't say area 0 because area 0, this network, this is the one advertises to this information. It says R2 and R4 exist in this interface, in this area 1, and it's true because R4 and R2 exist on this interface. True, R4 and R2 exist, and the DR is R4 advertising router. It is advertising its own connected network. And here you can see the link that R2 is advertising is 1. The link is R4 is advertising is 2. So if you go show IB Ospf database router, then we have to see R2 is advertising 1. So advertising, you see, is R2 is advertising 1, and the link is advertising is this one, because this one is the router ID. So router ID of this segment. So this segment R4 is the router ID, and as you can see, and as you can see, R4 is advertising 2, because we said here R4 is advertising 2. Where is he? R4 is advertising 2, we said, and R2 is advertising 2, and R4 is R2 is advertising 1, and R2 is advertising 4. So R2 was advertising this link and just this link, and R4 is advertising 2, and the 2 is it is loopback, and it is connected IB interface, connected interface. So if we say network, we just type 2, then it says like this area, for area 1 we have R4 and R2 connected to. That is LSA type 1 and type 2. If we go to LSA type summary, which is type 3 LSA, well, let me just go here. Type 3 LSA, this one is called type 3 LSA. It means R2 is a router ID for this segment. So R1 is a border area router, so anything length from R3 in area to from area 2 by R1, for example R1 length through area 2, this network, and if there are 100 networks here, it will length from area 2. So R1 will advertise to area to router 1 through area 0. So the area 0, R2 is connected to area 0. So R2 will advertise this to R4 as a type 3 LSA. And you can see R2 is advertising all this network. So all this network include R3 network, include because this network, because anything length from here, anything R1 length from here, plus anything length from OSPF, R2 will advertise to R4 to give the full information about. So that's what it is. Like now, R2 advertised, because this is the R2 router ID, it is advertising 3.3.3 that R1 advertising to R2, and R2 is advertising to R4. And as you can see, network 13, R1 is advertising to R2, and R2 is advertising to R4. And you can see R2 is advertising is unconnected. R2 is still, all these are R2. So R2 is called, this is called network summary LSA. That means this guy is giving a brief information, because R4 has no clue what exists in R2. So R2 says, if you want to reach the network call 3.3.3.3, or if you want to reach the network call 192.168.13.0 anything, please come to me. That's what it says about. Please come to me, so I will direct it to you. So now if I say show IP route OSPF, they are in the network, they are in the routing table as IA. So IA, that means it's LSA type 3 inter-area routes. You see, so link 1 was here, and now it is here in as IA routes, OIA. So that means O is OSPF, I is for inter-area, I is for inter, and A is for area, and R2 is an inter-area, and when the 12, because these are member of area 0, and these are member of is area 2. So if we try to ping it now, we can reach any network, because we are going to R3 to R2. So if we go trace route and take take like network 3.3.3.3, we are going to R2, R1, and finally to go to R3. And I hope this has been informative, and I will see you on the next lecture. On the next lecture. On the next